Okay, 3.3 is measures of central tendency and dispersion from grouped data. So we've discussed how to compute descriptive, sorry, it's rubbing my nose, to compute descriptive statistics from raw data, but often the only available data have already been summarized in frequency distribution tables, making it grouped data. Although we cannot find exact values of the mean or standard deviation without the raw data, we can approximate these measures using the techniques we're going to discuss in this section. So before providing a method for computing the mean from group data or standard deviation, we got to learn how to determine the class midpoint. Okay? Because raw data cannot be retrieved from a frequency distribution table, we assume that within each class, the mean of the data values is equal to the class midpoint, right? So we're just going to make the mean equal to the class midpoint. Classes are the same size. And so then we're going to multiply the class midpoint by the frequency. This product will be close to the sum of the data that lie in the classes. I hope that makes sense. Then we're just going to repeat that for each class and add them all up. So we'll get an approximate sum of all the data. Okay, so a class midpoint is the sum of consecutive lower class limits divided by 2. Once again, most of this stuff is easiest if we just get into the example and show what we're talking about. So here we have the formulas for the approximate mean of a variable from a frequency distribution table. And notice that they're exactly the same, right? Except if it's population, we call it mu. If it's sample, we're going to call it x bar. And x sub I is the midpoint of each class, right? F sub I is the frequency of that class. So we just multiply the midpoint times the frequency, okay, and then add up the frequencies. So it's still the same as adding up all of your values and then divide by how many you have, right? Add up all the ones you have. All right, so here's an example. The National Survey of Student Engagement is a survey that, among other things, asked first-year students at liberal arts colleges how much time they spend preparing for class each week. The results from the 2007 survey are summarized below. So approximate the mean number of hours spent preparing for class each week. Okay, so here's our data, but let's rearrange it, okay, into a more useful form. Yeah, let's put it like this. Same data. I just made my table look different. Okay, so first thing, we need our formula. So you might want to start keeping track of a page with the list of all these formulas on them. You don't have to memorize them for the test. You can have the formula sheet for the test. I'll provide you with a formula sheet. But you need to be able to understand the formula and use it, of course. So the formula to approximate the mean, since we have a sample, we're going to say it's x bar. And we're going to sum up the midpoint times the frequencies and then divide by the sum of all the frequencies added together. Okay, excuse me. So I need my midpoint up here. All right, so what it said was add the lower class limits. So 1 plus 0 and divide by 2. So 1 divided by 2 is 0.5. 6 plus 1 is 7 divided by 2. 11 plus 6 is 17 divided by 2. 16 plus 11 is 27 divided by 2. 21 plus 16 is 37 divided by 2. So 37 divided by 2, what's that? 18 and a half. Whoops, 18 and a half. 47 divided by 2. 57 divided by 2. 25, 28 and a half. Let's see, 56, 57, right? Okay, and so to find our last one, I know that my next class would start with 36, right? So 36 plus 31, 67 divided by 2. Okay, so we find the midpoint of each class, and then I multiply it times the frequency. So notice what happens here with this 0 value. It just kind of takes care of itself, right? Multiply now 130 times 3.5. 455. Multiply 250 times 8.5. 2125. Multiply 230 times 13.5. 3105. 180 times 18.5. 3330. 100 times 23.5, 2350. 60 times 28.5, 1710. And 50 times 33.5, 1675. Okay, so notice I need the sum of this column, the sum of that column, and the sum of this column. Okay, so this one I've already got one of the numbers in my calculator. So 1675 plus 1710 plus 2350 plus 3330 plus 3105 plus 2125 plus 455 is 14,750. This one might be easier to add without the calculator. 5, 6, 7, 8, 10, 8, 99, 29, 7,000. Okay. Okay. Oh, I nearly hit the erase again. Oh my word, that would have been awful. Okay, instead, I'm just trying to go back to red. Okay. So we've got 14,750 divided by 1,000, or 14.75. And I think I'm going to write that over here because I think we're going to need that later. Okay, so not too bad, right? An approximate mean for this data, even though we don't have the exact values. Okay. When data values have different importance or weights associated with them, we compute the weighted mean. For example, your grade average is a weighted mean, right? Each test grade is weighted more, is more important than each homework grade. Your final exam grade is more important than a test grade. So the weighted mean, which is x bar sub w, of a variable is found by multiplying each value of the variable by its corresponding weight. You add all those products, divide by the sum of the weights, and it can be expressed using this formula. So notice it's very much the same, except we're multiplying the weight times each value instead of the frequency. So W sub 1 is the weight, X sub I, that should not say weight there, that's a typo. Okay, so that should say the value of the ith observation. Okay, but once again, let's look at an example. Okay, Bob goes to the, by the way, that's cute, nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate, 1.5 pounds of cashews. The raisins cost $1.25 a pound. The chocolate covered peanuts cost $3.25 per pound, and the cashews cost $5.40 a pound. What is the cost per pound of this mix? Okay, well, let's see. He had 1 pound of raisins, and the raisins are $1.25 a pound. And then he had 2 pounds of chocolate covered peanuts for a cost or a value or a weight of $3.25 a pound. And then he had 1.5 pounds of cashews for a value of $5.40 a pound. And then we just divide it by how many pounds he had. 1 plus 2 plus 1.5. Now, remember when we put this in our calculator, we must have parentheses around the numerator and the denominator, right? To tell the calculator the correct order to do it in. So we have 1.25 plus 2 times 3.25 plus 1.5 times 5.4 and divided by 4.5. All right. To get, now here's what I got. 5, I did not get 5. I got 3.52222. And so because this is money, it goes without saying that you always round to the nearest cent. So your final answer will be $3.52. Okay, so once again, not too bad, right? Okay, the procedure for approximating the standard deviation from group data is similar to that of finding the mean from group data. Again, because we do not have access to the original data, the standard deviation is approximate. Okay, so here's our formula. Okay, notice they're also very similar, but just like the difference in population standard deviation and sample standard deviation, we divide by n minus 1 down here, right? And just n if it's population. Okay, here is an algebraically equivalent formula, right? It's just had some algebra performed on it if you prefer it in this format. But once again, probably the easiest thing to do is let's just see an example. Okay, so the National Survey of Student Engagement is a survey that, among other things, so we have the same data, right? Same data. So once again, let's rearrange it into a more useful form for us because I need to add some columns over here. Okay, one thing I also need to know, let's put our formula up here since all this isn't fitting on the same page, and because it's sample data, we're going to use S. All right, just so we can be aware what I need to figure out in my table. So we're going to have the sum of x sub I minus x bar squared times f sub I all over the sum of f sub I and then minus 1 because it's a sample. Okay, so that means I need x bar, and we just did x bar. Let me see if it should still be on my calculator. 14.7. Oh, I wrote it over there. Yay. X bar is 14.75, right? Okay, so look at the formula. I have my frequency. Okay, I still need those class values. And I need to subtract x bar from it, and then I need one where it's squared multiplied by the frequency. Okay. All right. So let's do our x sub I. And notice we're going to repeat some of this work, and it doesn't hurt us to see it twice. But if you're working on a problem, this same problem, you really don't have to make this chart twice. You make the entire chart, and then you pull the pieces that you need for, to get your mean, and then continue the chart. So I wouldn't have to find these class midpoints again. 1 plus 0 is 1 divided by 2. Okay, 7 divided by 2, 17 divided by 2, 27 divided by 2, 37 divided by 2, 47 divided by 2, 57 divided by 2, 57, 28.5, and then once again 36 plus 31 would be 67 divided by 2. Okay, now I need a column that is this value minus my mean. Okay, I might go ahead and just square it while I'm doing that. I can have 2 separate columns, or let's just do it all at once. I was going to try to fit it all across, but I'm going to be squished, so let's just do it all at once. Okay, so I'm going to have 0.5 minus 14.75, and then I'm going to square that. 203.0625. Okay, now I've got 3.5 minus 14.75 squared, 126.5625. 8.5 minus 14.75 squared, 39.0625. 13.5 minus 14.75 squared, 1.5625. Okay, 18.5 minus 14.75 squared, 14.0625. 23.5 minus 14.75 squared, 76.5625. Okay, 28.5 minus 14.75 squared, 189.0625. And 33.5 minus 14.75 squared, 351.5625. Okay, so I've got this part. Now I've got to multiply it by the frequency. All right, so my last column. Okay, so 0 times this. Okay, 130. I'm going to start down here just because I already have this in my calculator. So I'm going to do that times 50 times 50. 17,578.125. 189.0625 times 60, right? Keep up with the columns that we're doing. 11,343.75. 76.5625 times 100. I did not need to put that in my calculator, but I already did before I realized what I was multiplying by. 14.0625 times 180, 2531, whoops, 2531.25, just so that I've got to remember these values, so I want to make sure I can read them. 1.5625 times 230, 359.375. Okay, 39.0625 times 250, 9765.625, and finally 126.5625 times 130, 16,453.125. Okay, so I need the sum of this, right, and the sum of this. Oh, we already know that's 100 from before, right? That one was the easy one to add up. Not 100, 1,000, sorry, 1,000. Okay, so let's add this up. I've got the 1653.125 in my calculator, so plus 9765.625 plus 359.375 plus 2531.25 plus 7656.25 plus 11,343.75 plus 17,578.125. All right, to get a 65,687.5. Okay, so now I've got the square root of 65,687.5 687.5 divided by 1,000 minus 1 divided by 999. Let's see what that is. The square root of 65687.5 divided by 999. For 8 point, and I'm going to round this to 3 decimal places just for our sake right now, 8.109. Okay, I'm going to write this down too. Okay, so tedious but not difficult, right? Tedious but not difficult. So you may be thinking, why do we have these awesome calculating machines then? Okay, all right, let's look at doing it in the calculator. Okay, so if I was going to do this same problem in the calculator, I had noticed that your instructions, which remember, technology tips from the text, I made a module for that. This one's not quite accurate. Okay, so we need to add a little bit to it. So that's, I just cropped off a piece of the photo that's in there. And really, as far as this class goes, the TA 8384, or the calculator section is mainly what I'm interested in. I always, include the StatCrunch and Excel and stuff just for your information, but, calculator steps. Okay, but if we're going to do this same thing in our calculator, so notice what it says here. It says enter the class midpoint. Oh, I erased all of that. All right, so I'm going to go up and find the midpoint again. All right, we like finding the midpoint. That's why we're doing it 4 times. Okay, why is that weird pen up here? That makes it hard for me to write. Let me see what's happening. Okay, better. Ah, no. What caused me to get that? What caused that? Well, okay, I can't spend forever messing with that, but I'll try to make that work. It's hard enough to write with this thing anyhow, but now I've got to write below my mark instead of above, so it's just weird when that's on there. Okay, 1 plus 0 divided by 2. 7 divided by 2. 17 divided by 2. 27 divided by 2. 37 divided by 2. 47 divided by 2. 57 divided by 2. 57. 28.5. And once again, if we put 36 down here, we'd have 67 divided by 2. Okay. So notice this says enter the class midpoint in L1, and they're expecting that you already kind of know how to go into your stat menu here. So to start with, really, we're going to hit the stat button on our calculator and edit. And it tells you that. Do it by pressing stat and then selecting edit. Okay, if you have values in here already, here's one thing it didn't say. So move your arrow up to the L1 list, hit clear, and then when you move down, it should be cleared. So all of your lists that you are finished with, you might want to go over and clear them out. Okay, so now we are going to enter, okay, the midpoint in list 1, L1. So I'm going to enter this midpoint. So 0.5, excuse me. I'm just going down my list, entering this 8.5, 13.5, 18.5, 23.5, 28.5, and 33.5. Okay, then you move over with your arrow into L2. Okay, and in L2 you enter the relative frequency. So 0, 130, 250, 230, 180, 100, 60, and 50. And notice it'll tell you 1, 2, 3, 4, 5, 6, 7, 8 to just make sure. At the bottom on your last entry it tells you L2 entry 8. It has an 8 in parentheses. Okay, now after we get our data entered in our lists, we go back and hit the Stat button. You go over to Calc, slide over. Number 1 says 1 variable stats, just like that. So we're going to hit Enter, or number 1. Now, what's unclear here is it says in the menu, select L1 for list and select L2 for frequent list. Okay, so what I need to do, and then highlight calculate and press enter. Well, actually after I enter this, after I hit the 1 variable stat, so you might want to update this information, then I'm going to, if you look on your calculator, look above the numbers 1 and 2, right? The yellow, you've got L1 and L2. So do second and hit number 1, and you'll see that L1 gets put up there. And then a comma, and then do second and hit number 2 so that L2 gets put up there. So what your calculator now looks like on your screen is this. Okay, and then hit enter. Okay, and so it told me that X bar is 14.75, and if I go down until I look at S, it tells me is 8.1088, and so looking back, that's what we had by doing it manually, right? Okay. Let me know if you need anything.